So these are all of our notes over 4.2, rational functions and graphs. This is a lot of information. This is eventually going to be things that you have to have fully memorized, of how to find vertical asymptote, horizontal asymptote, and all that kind of stuff. So you have seen this before. It's just maybe been a minute since you kind of thought about it. So vertical asymptotes, also called asymptotic discontinuities, okay? Basically another word for it just can't cross that thing, right? It's a discontinuity point or line that can't be crossed. So we're going to determine the values of x that make the denominator. So we're going to do a lot of highlighting on this page, color coding, and give some examples. So if you need markers or anything, there are markers over there or colored pencils if you're on paper. But make the denominator equal to 0. So that is your vertical asymptote. Abbreviated with VA, which means we might have to do some factoring. So hopefully you remember how to factor. And then when we're finding horizontal asymptotes, sometimes oblique asymptotes. What does an oblique asymptote look like? If you show me with your arms. What does it look like? Is it like this? Is it like this? Oblique is a slant. Okay, so oblique is at a slant. We consider what happens to the function as x approaches positive or negative infinity. So horizontal asymptote is all about end behavior. You can have a graph cross a horizontal asymptote, but a graph will never cross a vertical asymptote, okay? So for horizontal asymptote, we got to look at the degrees of things. So I'm going to choose a different color here. Horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, so keyword here being greater, there is no horizontal asymptote. Okay, so if I gave an example, I'm going to zoom in here and put an example down. So like if I had a function, the numerator has to be greater. So like if I had, I don't know, we'll just keep it simple, x to the 5th over x to the 3rd. Okay, the degree of the numerator is 5. The degree of the denominator is 3. Okay, you're looking at the highest exponent there. So if this is the case, this would mean there is no horizontal asymptote. I'm actually going to skip down to letter D real quick because it's also talking about greater than, and I want to explain what you would do in that case. So if the degree of the numerator is exactly 1 more than the degree of the denominator, there is still no horizontal asymptote, but there might be an oblique asymptote that we have to check for. Okay, so to find it, we would divide and then disregard the remainder. Okay, so if it is exactly 1 more, so for example, f of x equals x to the 4th over x to the 3rd, or you might have some other things with that. It could be like 4 plus x to the 4th. But if the degree is 1 more than the degree in the denominator, you would have to divide it to find out if there is an oblique asymptote, which we'll get into more examples in a bit. Okay, other ones. Letter B, if the degree is less than, the numerator is less than the degree of the denominator, then your horizontal asymptote is y equals 0. So if I had something as such, f of x equals, maybe let's do like 4 plus x to the 7th divided by x to the 8th minus 3. Okay, the highest degree in the numerator is 7, highest degree in the denominator is 8, so it is less than, which would mean my horizontal asymptote is y equals 0. And then the last horizontal asymptote on there talks about if they are equal. So if the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is the ratio of the leading coefficients. So for example, if we had f of x equals -3 minus 4x divided by 3x, the degree of both of those would be what? 1, right? So I would look specifically at the numbers in front. So the numbers in front of x, -4 and +3. So my horizontal asymptote would be y equals -4/3. Okay, so that is our 4 different cases for horizontal asymptotes and what could happen depending on the degree. So we have to look at the degree in order to figure this out. Number 3 talks about if we have discontinuities, okay? That's if we have a value of x that makes both the numerator and the denominator equal to 0. So if I had something, normally it's given to you in like a quadratic and you have to factor it, but if I gave you it factored like this, maybe f of x equals 2x minus 3 times x plus 4 divided by x plus 4 and 3x minus 7. If you got something like that after you factored, x plus 4 simplifies to give you 1, right? So then you would have a whole specifically at when x plus 4 equals 0, right? Because if I had 0 in the denominator, we can't have that. We can't divide by 0. So what would make that 0 for x? -4, right? So we'd have a whole at x equals -4, depending on whatever our function looks like when we're graphing it. We would denote that with a open circle on our graph. I said this once already, but I'll say it again. A graph of a rational function is never going to cross the vertical asymptote, but it can cross anything that's not vertical. So it can cross a horizontal or an oblique asymptote. So we will have to test some more points today to make sure we know kind of what the end behavior is. It's not going to be just a parent function of 1 over x or 1 over x squared. Okay, and then underneath here are just kind of 8 steps to just make sure that you are checking as you are going through and graphing your rational functions. You don't necessarily have to do these in order. I kind of jump around when I'm doing these, but this is just a fail-safe to make sure you did every single thing when you are graphing, okay? First thing here is your denominator. We are going to set equal to 0 to find your your vertical asymptote, which is also mentioned above, but to find your vertical asymptote, set them equal to 0 in the numerator. Denominator, I said it wrong. There we go. Denominator, set it equal to 0. Okay, so denominator is vertical asymptote. To find our x-intercepts, because we're going to try and figure out where do they cross the x-axis, we need to factor the numerator if it needs to be factored, and set that equal to 0 to find the x-intercepts. And if the factor in the numerator and the factor in the denominator are the same, those would simplify and give you a whole, right? So we'd have a whole at that value. Just like finding x-intercepts, we also have to find y-intercepts. For finding y-intercepts makes sense if you think about your graph, right? On your y-axis, your x value is 0, so you are plugging in x equals 0, and you are solving that value to figure out what y is for your y-intercept. Then we will use our horizontal asymptotes rules up above to figure out what our horizontal asymptote is. And then make sure you plot everything on the graph. And then choose a few more points as necessary to figure out what is happening as it approaches each of the asymptotes. Okay, we will need to be able to do this by hand, so we can't just rely on plugging it into the calculator, okay? any questions on just this stuff right here? Hopefully it sounds familiar. Yes? Okay, good. All right, so we are going to first start on these first few examples. We are just finding the asymptotes and the intercepts. We are not graphing it quite yet, okay? We're going to graph 2 of them today, and we'll save the last 2 more complicated ones for next class. So if I look at this example here, I am given a function, f of x equals x plus 1 over 2x squared plus 5x minus 3. If you could factor either of those, that is what you should do to start. Can we factor one of those? Yes, we can. Okay, so let's go ahead and factor the denominator, because x plus 1 is already done for us. Now, how many of us like guess and check? Anyone? Guess and check? A few of us? How many of us do factor by grouping? How many of us don't remember how to factor? Okay, thanks for being honest. Okay, so I'm going to show you the guess and check real quick, but then I am also going to show you the grouping, because grouping will work every single time. But sometimes you guys can make better choices when things like this problem are here, because remember, when we're factoring, we're looking at what multiplies together to give us that first number. That goes in our first space here, right? So what is the only thing that multiplies together to give me 2x squared? A 2x and a 1x, right? So I could put in here 2x and 1x right away, because there's nothing else that factors to give me 2. Now, the other number that we have to look at is this second term here. That has to multiply to give me that negative 3 at the end, okay? What's the only thing that multiplies to give me negative 3? 1 and negative 3, or negative 1 and positive 3, right? So I know that 1 or 3 could go there, or 3 or 1, and obviously vice versa with negatives, right? And then you're kind of thinking in your brain, okay, well, if I multiply 2 by that number, and I have a number times x, I need to add to get 5 in the 5 in the middle there, okay? So one of them has to be negative, one of them has to be positive. Well, if I do 2 times a negative 3, that gives me negative 6x. I don't want that. I want positive 6x and a negative 1. So if I would multiply those two things together, when you actually FOIL it back out, you would get negative 1x here and positive 6x, which gives you a total of that 5x. Now, if I totally kind of lost you there, that's kind of what guess and check is, so that's okay. You don't have to do it this way. I will also show you the grouping way that will work every single time, okay? Any questions on this way? Okay, if you don't like it, that's okay. Here's the other method. Let's do factor by grouping. So factoring by grouping means that I am looking at 2x squared times negative 3. That gives me negative 6, right? And then in my product sum puzzle on the bottom, I'm going to have that 5. So now what multiplies to give me negative 6 but adds to give me 5? Wait, what?
Negative 1 positive.
Yes, negative 1 positive 6, okay? That is going to replace your b term. So I'm going to rewrite this expression right here as 2x squared minus 1x plus 6x and then minus 3. Okay, I'm only replacing that b value. Okay, now we can factor it by grouping. So I can think about splitting this up into 2 pieces because I have 4 terms. And you're looking at what is the GCF of the left side? What can I take out of 2x squared and 1x? A 1x, right? So I'm taking out a 1x. What can I take out of 6x minus 3? A 3, right? Okay, sometimes people jump straight to the answer. I'm going to show you what actually mathematically is happening. When I take out that 1x and I divide it, I am left with 2x minus 1. Do we follow? And then when I take out this plus 3, what's really happening is I'm left with 6x divided by 3 is 2x. Negative 3 divided by 3 is negative 1. And then the real math that's happening is that this is a common factor out of these 2 terms. So we are going to take that out, and it is going to become 2x minus 1 times that leftover stuff of 1x plus 3. Okay? So hopefully that at least looks something similar to what you did before. If you have no idea how to factor or what I just did, please, please, please come in and see me and we can go through some practice problems, okay? So I'm going to rewrite this up here underneath my x plus 1 as 2x minus 1 and x plus 3. Okay, now that I've got that factor, the rest of this is going to be a lot easier to figure out. So we are going to start by finding our asymptotes. My vertical asymptote, vertical asymptote. What do I do to find my vertical asymptote? What does it say on that previous page that we just looked at? Vertical asymptote. Yeah. Set your denominator equal to 0, right? So I'm going to set those two factors that we just had, 2x minus 1 and x plus 3 equal to 0. Okay, zero product property tells me I can set either of these equal to 0 to figure out what my x value is. So I'm actually going to have two vertical asymptotes for this problem. And if I solve both of those, I end up with 1/2 and -3. Okay, please make sure you highlight or circle or somehow denote which asymptotes are where, and make sure you label it as like x equals. If you just put vertical asymptote 1/2, that will not be acceptable. So I need to make sure you guys are writing equations when you should be writing equations, and writing points for intercepts when we are writing, or when we should have a point, okay? So that's our vertical asymptote. Let's look at horizontal asymptote. Horizontal asymptote, I look at what? My degrees, right? So over here, if I'm looking at the degrees, the highest degree of the numerator is a 1. What's the highest degree of the denominator? A 2. So it is 1 less than the denominator. So that would mean what? If it's 1 less? It's 0, right? So it's 1 less. I'm just going to kind of write y here. It is 1 less there. So then we have y equals 0. So again, the repetition is going to help, but it's just, we got to remember, what do we set equal to 0? When do I look at exponents and degrees? And when do I plug in 0 for things in order to find intercepts? Okay, so we found both our asymptotes. Now we're going to find our intercepts. Okay, x-intercepts. How do I find x-intercepts? What do I got to do? Set the what? Set the top equal to 0. So the top is x plus 1. X plus 1 equals 0, so x would equal -1. If I leave it like that, that means it's a line. Is an x-intercept a line? No, so I'm going to write this as a point. The point -1, 0. I will take off points if you don't write it as a point on your quiz or your test, okay? All right, y-intercept. How do I find my y-intercept? Plug 0 in for x's, right? So I usually like to just use the original equation instead of the factored one, but it should work either way. So I'm going to plug in 0 anytime I see an x. So I've got 0 plus 1. And then I've got 2 times 0 squared. Can we just write 0? And then I've got 5 times 0, which also is 0 minus 3. Okay, some of you guys might go immediately to your answer. Others of you might want to write it out like this. I'm writing it out like this so you see what I did. And then I would get -1/3. Now again, if I leave it as y equals -1/3, that is a horizontal line. I want a point, so my point should be 0, -1/3. Any questions on this one? Okay. I think that you guys are capable of doing this next one all by yourselves. Okay? There's actually no factoring that needs to be done in this next problem. So I'm going to give you guys a few minutes right now. Try it out. In a little bit, I will start writing my work up here for you to see. And then if you have questions, we can go over them. All right. Example 3. We got 2 more left for today. So find asymptotes, intercept, and graph. So starting out with my vertical asymptote. The vertical asymptote, what do I need to do? For vertical, do I set the top or the denominator equal to 0? For vertical, denominator, yes. Set the denominator equal to 0. X minus 2 equals 0, so x equals 2. Okay, also, thing to note, can I factor x squared plus 1? I don't believe so. No, you actually cannot. Okay, you cannot factor that. So we are good to leave that. Horizontal asymptote, okay, is the degrees. So I'm looking at 2 over 1, right? So what does that mean? Unless it is point D on that front page, which says if it is 1 greater, then there might be an oblique. So we've got to check and we've got to do long division, okay? So we need to take x minus 2 and divide by x squared plus 1. Now, x squared plus 1, it's missing a middle term there. So we're going to write this as x squared plus 0x plus 1. Okay, we got to have a placeholder for that value in order for us to divide this correctly. Yes, question?
Sorry, why do we have to do that again?
Because the degree is 1 greater than the denominator.
Well, yeah, but for the 0x.
Oh, so that way we don't forget when we're multiplying to not, like, keep it in our answer. Like, so let's start multiplying and I'll show you. When I ask myself what times what gives me x squared for x, what would I put up top? I would put x up, right? So x times x is x squared, and then x times negative 2 is negative 2x. Now, if I didn't have that 0x there, then people might do the 1 plus the negative 2, and then that would be wrong. So just put a placeholder in there, kind of allows us to not make that mistake, okay? Good question, though. And then now we're subtracting. So I'm going to subtract that whole quantity, or in my life, I like to add. So I am changing the sign of everything. And I get positive 2x plus 1. So now we ask ourselves, what times what? Or sorry, what times x give us 2x plus 2? And I multiply that 2, and I get 2x minus 4. Okay, now I subtract these things, or in my case, I like to change the signs. So I am left with a remainder of 5. Now, if you look back on the previous page, for remainders, it says to do what? Just ignore them, okay? For our oblique asymptotes, we don't need them. This right here is my oblique asymptote. So horizontal asymptote really is none, okay? But my oblique asymptote is y equals x plus 2. So that is a linear function, so that looks like a line, right, at x plus 2. All right, we've got our asymptotes. Now we got to find our x-intercepts and our y-intercepts. So x-intercept, to find that, what am I doing? Set the top to 0. So x squared plus 1 equals 0. If I solve that, I get x squared equals negative 1. Can I do that? Can I finish solving that?
No.
No. So there are, in fact, no x-intercepts. None, NA, however you want to write it. It never crosses the x-axis. But y-intercepts, I will have. Okay, I need to figure out what my y-intercept is if I plug in 0 for x, right? So I've got y equals 0 plus 1 over 0 minus 2, or negative 1/2. Should I leave my answer like this? No, we should write it as a coordinate. So x first, 0, negative 1/2 is your y value. Okay, now we actually have to graph these things and see what happens. Let's start by graphing our asymptotes, okay? x equals 2, we got to remember, is that a vertical line or a horizontal line? Vertical, hence the vertical asymptote, right? So at x equals 2, I am plotting a point, or a graph, or a line, whatever the word is. It's almost the end of the day. Here we go. X equals 2. Okay? Dashed line. Next, what I'm doing is I am graphing the oblique asymptote at x plus 2. Okay? So that means I'm starting on the y-axis at 2. Hopefully you remember how to graph a line. What am I going to do from there? Up 1 over 1. That slope of 1 in front of x means up 1 over 1 would create more points for me. And then that would create my dashed line, which might look kind of awful on here because notability is way better than explain everything. But we get the idea. Okay? That's my oblique, and that's my vertical. Okay? So we're not crossing the x-axis at all. We are crossing the y-intercept at 0, negative 1/2. So I'm going to plot a point right there. And now we need to figure out what this graph is going to look like by picking some points. Okay? So let's pick some points here. Let's pick some points on the left and the right and figure out what happens. Okay? Now, one thing else to note is that your graph will always approach the vertical asymptote but never cross it, right? So automatically I know that this is going to go down towards this vertical asymptote. But I'm not sure what's happening on the left side. I don't know if it's going to like cross the graph. I don't know if it's going to go down and follow the asymptote. So we got to pick some points to find out. So let's maybe pick like negative 3. If I plug in negative 3, okay, you can either just think through this or plug it in your calculator. I'd have negative 3 squared would be 9 plus 1 over negative 3 minus 2. That's negative 5, right? So that would be 10 over negative 5, which is negative 2. So plot a point negative 3, negative 2. Okay. It's pretty close. I'm still not quite sure. Is it going to come back up? Let's pick another point. If I go, let's just go negative 10. Let's pick a negative 10 point. Okay, plug in negative 10. I get 100 plus 1 over negative 10 minus 2 gives me negative 12. So 101 divided by negative 12, what's that approximately? It's like, I think 8 point something. I can't do that mental math in my head. Can someone check for me? What do I get? 101 divided by negative 12 approximately. What's that give me? Negative 8.41, thank you. At least I wasn't that far off. Okay, so at negative 10, I'm going negative 8.41. So that's going to be down here. Okay, it still isn't crossing that asymptote. So I feel pretty confident here. We can go ahead and sketch our graph. It is approaching that oblique asymptote, but it is not crossing. It's going to continue forever to get really, really close to that, but never actually cross it. Okay, then we got to pick a few points on the right side of my vertical asymptote because we don't have any idea what's going on the right side. Is it going to be up in the little space above? Is it going to be on the side of that? Where is it going to be up there? I don't know. So let's pick a point at 3. Let's plug in 3. And I would get 10 on top and 1 on bottom. So at 3, my point is going to be at 10. There's a 10 by 10 grid, so it goes all the way up to the top. Okay, we know that it's going to be approaching our vertical asymptote, so I can go ahead and assume that that's going straight up. But now I need to figure out, is it going to cross the oblique asymptote or is it not going to? Let's pick a few more points. Maybe we pick 5. Let's plug 5 in. 5 squared, 25, plus 1, 26. Divided by 3, it's like 8.67, right? So we plot that point. Does it cross yet? No, it does not. 8.63. Is that 5? That's not 5. 3, 4, 5. Oh. Okay. So we're getting close to that asymptote, but I'm not really sure. Are we going to cross it or not? Let's pick one more point just so we are for sure. maybe let's pick 7. Okay, if we pick 7, 7 squared gives me 49, plus 1 is 50, and 50 divided by 5 would be 10. That's an easy one to plot. So at 7, we're going to be back up at 10. So again, it's going to be really, really close, but it doesn't seem to look like it's going to cross. So we can go ahead and assume and sketch our graph. Okay, you might sometimes be asked about domain and range still. Okay, so as far from the left as possible, I would go all the way still to infinity, right? And I could go all the way up until this vertical asymptote at 2, right? And then I can go from 2 all the way to infinity, okay? Your range will be a little different. And I don't really think I would ask you about the range because you're not really sure exactly what's happening up in the top there. Okay. All right. We got one more quick example of example 4. I promise you it'll be like probably less than 2 minutes long, maybe even a minute. Okay. This one was a little bit longer. So example 4. Ignore this calculator test point thing for a second. We're going to talk about calculators mostly next time for plugging things in. So make sure if you don't have a calculator by next class. Get one from the library, or if you're buying one or whatever, try and have your calculator next class. I only have 10 in here, so I want to make sure everyone or their partner can share one. So, okay, if I look at this, x squared minus 4, what can I do? I can factor that, right? That's a difference of squares. So this is a quick and easy one, or hopefully should be. The only thing that multiplies to give me x squared is x and x. And then what are my other numbers going to be? Plus 2 minus 2. Okay, well, what simplifies to give me 1? X minus 2, right? So our function is just f of x equals x plus 2. That's our entire function. What's that going to graph like? It's a line, right? It's linear. It has an exponent of 1. Okay, however, we have a hole at when x plus 2 equals 0. So we're going to have a hole at what value? Negative 2. Okay, so we just got to plot this graph real quick here. To graph this, I'm starting at 2 on the y-axis, and I'm going up 1 over 1. Oh, sorry, guys. Yeah, that should be, you're right. I put the wrong thing. Yep, let's see. Okay, this was x minus 2. That's the one that we canceled out. Okay. So now at 2, I'm going to have an open circle. Everything else will be a closed circle all the way down. Okay? Any questions? Yeah.
I just kind of wanted to know about like what this hole is, like the whole part.
What the hole is? Like, so since they simplify on the top and the bottom, like right here, x minus 2 and x minus 2 have the same factor on top and bottom, since they cancel out, this, if I plug in 2 down here, it's going to make that equal to 0, which means it's not going to be true in the equation. Does that make sense? So we can't have that point closed in because the function doesn't exist at 2. Yeah, good question.